Hello everyone, wishing you all a very good morning. I hope all of you are happy, fine, safe and healthy. Hello Kiran, how are you doing better? Am I audible and visible to all of you? Can you see me? Biram, Niharika, Preeti, Tanu, Tarun, Vasant, everyone is there. Good afternoon Tarun, how are you? I hope we are doing fine. Good afternoon Abhiram. Okay, start the class with the same old routine. Keep your mobile cameras off. Sit in a place where you get good network. If you have to send any message, send it on the my ID of Astic or send it to everyone, right? What else? Yes, I think today is Monday, and as we all have it, probably you had an exam last day. Yes or no? You had a test on Sunday. How did you do in the test? How many of you appeared for the test? First of all, that seems a pertinent question. How many of you appeared for the test? Abhiram appeared. What about the others? Tarun also appeared. Good. Only two people? Tanu, Vasant, Preeti, Niharika, Kiran, Vishal do not appear for the test? No one. Okay, Tanu also appeared. Great. What were your scores, Abhiram, Tarun, Tanu, in physics overall? Tell me so that I can see where are you standing right now. We have gone into relative motion also in this test. So how was your performance? I'm fine, Tarun. What about your test marks? Abhiram is saying I got behind, sir, because my biology wasn't there, so I did not get extra time. Okay. There was no biology test this time. Okay. Tarun, 115. Good. Not very good. What about you, Abhiram? 120. Good. It's a good score. Tanu, 118. It's a good score. What about the overall score, Tarun, Abhiram? There were only two, only physics and chemistry. No biology this time. Is that so? 45 questions in physics, 45 questions in chemistry. Okay. Tanu, Abhiram, what were your overall scores, Tarun? What were your scores in chemistry? Okay, overall is 230. Okay, so it's almost same for physics and chemistry. Not bad. Not bad at all. Okay, Tanu, see, there are times where your one paper will go good and the other paper not so good. But see, this is how life is. This is how life is. You will have to live with it, and you'll have to understand that all these ups and downs you'll have to go through. 212 is a good score, Tarun. Tanu, Abhiram, 215. Good score. Not bad at all. I mean, considering you only had physics and chemistry, normally to have time for physics and chemistry, you must score heavily and quickly in bio. So if there is no bio, you would have this. I'm happy with your overall scores. Hard. Physics paper was hard. Is that so? Yes. It's difficult to manage time when you don't have bio. Yes. Bio is the thing that gives you time in this because the number of questions are too much. 45 questions is just too much. If you don't have any bio, to do 45 questions in one hour is too difficult. I know that it's difficult. Anyways, here is the paper for you. A ball is projected with a kinetic energy E. Here we are talking about kinetic energy, half mv square. Kinetic energy E at an angle of 45 degree. At the highest point during its flight, what will be the kinetic energy? At the highest point, if the initial velocity is u, at the highest point it only has horizontal velocity. Horizontal velocity is u cos 45, u by root 2. So kinetic energy becomes v square, u square by 2. So it becomes half. It's as simple as that. See, questions are simple. But again, you'll have to find time to solve this question. A stone is thrown at an angle of theta to the horizontal, reaches the maximum height h. Time of flight. Easily calculate the time of flight is given. From that time of flight, we know the maximum height. From maximum height, you can calculate u, initial velocity uy or u sine theta, and then you can find out the time of flight. Question was simple. The horizontal range is 4 root 3 times its maximum height. So range is 4 root 3 times h. I gave you the formula between range and h. 1 by 4 tan theta. H by r is 1 by 4 tan theta. If you remember, from here you can find out the angle of projection. Basically, you must understand, beta, that if you can remember all those combinations of all those formulas that we have done, different combinations, I'm sure you would be able to solve any question. Question number 4, a ball is projected upwards from a tower with a velocity of 50. That this question is tough. Making an angle of 30 degrees, the height of the tower is 70 meters. How many seconds from the instant of throwing will the ball reach the ground? See, as time progresses, you must become smart. The reason of giving these papers is to make you smart. You have to see which question is going to take more time and which question is going to take less time. This question was question from a tower, and then you are throwing something like this. Now, normally, this question will take some time of you, some of your time. So you must be cautious that you just mark this question. Let me not try this now. Let me try it afterwards when I'm left with time. If this question takes 5 minutes of your time, you might still get the answer, whatever the answer is. I'm not concerned with the answer. Whatever the answer may be, you must still get the answer. But if you have wasted 5 minutes, that's not good enough. Because in 60 minutes, you are supposed to solve 45 questions if there is no bio. In 60 minutes, 45 questions for that means for one question, you have 60 by 45. That is 4 by 3. 1.33 minutes for one question. You're giving 5 minutes for one question. You're actually taking the time of 4 questions to solve that one question. So you are taking 16 marks for 4 marks. Not good. Not a good strategy. So such questions should be left. Are you getting my point, everyone? You have to get smarter. How many of you attempted this question? Question number 4. How many of you attempted? This question will take some time for you to solve. If you attempted this question, you would have missed marks in the easier one. How many of you attempted this question? No one? If no one attempted it, good. You did the right thing. Tanu attempted it. Tanu, how much time did you spend on this question? Any idea? Did you get the right answer? Next question. And how much time did you spend? Maybe this question took away the time of 4 questions. You have to be smarter. Tarun is raising hand. Tarun also, I think, attempted this one. How much time, Tarun, did you take for this question? I'm sure it would have taken more than 2 minutes, 3 minutes, 5 minutes. 4 to 5 minutes is what I expect. See, Tanu, you got the answer. 4 minutes. Tarun, 4 minutes means you have given the time for 3 questions in one question. You have to be smarter. You have to be smarter, beta. Smarter. Get smarter and you score bigger. So if you, instead of spending 4 minutes on this question, you could have spent 1.33 minutes multiplied by 3 in 3 questions literally. Probably you could have got 12 marks instead of 4 marks. See, that's how you get smarter. I know you can solve this. I know you would be able to solve this, but the matter is time. 2 bodies are thrown up at an angle of 60 and 45 degrees with the horizontal. Both attain the same vertical height. That means their vertical velocities are same. What with the ratio of velocity? So u1 sine theta 1 will be equal to u2 sine theta 2. These questions can be done in seconds. Try these in every exam, especially in chemistry. I cannot say about biology because biology questions are straight away forward, straight away yes or no. You know it or you don't know it. In physics, you will be encountering 1 or 2 questions out of 45. Just take this. At least 5 to 7 questions will be those questions which would be somewhat difficult. These 5 to 7 questions will take somewhere around 3 minutes, 2 to 3 minutes. So these questions will take away your 21 minutes, literally 15 to 21 minutes. Now you are left with only 49 minutes or 39 minutes. Now, at least 30 questions would be there that could be solved in less than a minute. Somewhere around 45 seconds, you should be able to solve it. One question for 45 seconds. If you solve 30 questions on that, on every question, you're taking 15 seconds left. So you will be basically able to do it somewhere around 20 to 25 minutes. 20 to 25 minutes, add it up. 25 minutes, you add it up with 21, you have 46 minutes. And you are left with 30 plus 7 questions. 7 questions for 15 minutes, 2 minutes on each question. The rest of the questions, which are somewhere around 7 to 8 questions, will be 2 minutes each. I hope you understand what I am trying to say. 5 to 7 questions will be there. We will take more than 2 minutes, somewhere around 3 minutes. You have to be smarter that you may leave this question in the first try. Just leave them. If you think that they are going to take much time. If you are not having time, if you're not able to save time from biology, this is how you go about it. There would be questions that you can just tick and go, tick and go, tick. This question was very simple. u1 sine theta 1 will be equal to u2 sine theta 2. So basically, the ratio of their vertical velocities, the ratio of their velocities is equal to the ratio of their sine of angles. That's it. It will not take. See, these questions are straight away simple. You will not even take 5 seconds to solve them. At which point on projection, acceleration and velocity are perpendicular? Acceleration is always downwards. Where is the velocity parallel? Highest point. See, not even 5 seconds. So there are questions. There are questions which will take only 5 seconds, 10 seconds. See, there are some questions which will take not even 5-10 seconds. See here, this one. I've done this question in the class. There are some questions which will not even take 5 to 10 seconds. See, similar question. Will not take even 5 seconds to solve it. Some question may take time. To save time for those questions. Are you getting my point, beta? Then there were question on train. Not easy to solve. But again, you should be able to solve. Okay, yeah, you had a section for thermo as well, so I can't comment on those questions. I can only comment on the question that I gave you. And this question was with relativistic speed. You don't know what is relativistic, so you should have left this question. Anyways, chalo. I hope you have understood the basic premise of giving you a paper and the way you should have attempted that paper. Shall we move ahead in life? I think we were doing questions on equilibrium. Yes or no? We were doing questions on equilibrium. Man, we had solved some problems there. I think I gave you a question for homework, but no one, I think, has tried that question. Has anyone tried that question? No one has tried it, as far as I know, because I did not get any answers. Again, that's your wish. If you don't want to solve the question, don't get time, well, doesn't matter. What we are going to do now is do this question. I hope you can see this. Something wrong with my Zoom. Okay, this one is what we are going to solve. In the arrangement, shown. What should be the mass of block A? What should be the mass of block A so that the system remains at rest? Just forget the second part of the question. The second part of the question is find the tension in the string. So you have to find the value of this mass M and the tension in the string. Do you understand the question, everyone? We are back live. We are always live. Back live to our topic that we are discussing, equilibrium. This is a question. 2 minutes. Solve it. Do we understand the question? Can I have some reason that we are there? We understand the question and we are solving it. Starting with Vasant, Tarun, Tanu, Preeti, Niharika, Irfan, Kiran, Vishal, BIPC 1303. How many of you are solving the question? Please raise hands. Okay. 2 minutes for everyone. Anyone could solve this question or help me in solving it? No one? Are you trying, beta? Shall I solve it? Okay. So first step is to draw a sketch. Sketch is already there. The second step is to draw free body diagram by isolating. All the three blocks are apart from each other. I will not spend my time in isolating them. Let us start with the tension. Let me call this tension as T1. T1. This becomes T1. This becomes T1. On the other side, we have a different string. So it's T2. This is T2. This is T2. And this is T2. So I have drawn the tension in the strings. Let us move now to draw the free body diagrams of this block. The only other force acting on this block will be the weight, which is downward, which is mg. G is 10, mass is m. It becomes 10m. This is 10m downwards. T1 is upwards. This is the free body diagram of block A. Do we understand this? Can I have some reason that we understand this, sir? The free body diagram of block A has been drawn. T1 is upwards. 10m is downwards. Waiting for your hands to raise so that I can move forward. Only Abhinam seems to understand this. Rest of all are sleeping. Starting with BIPC 1301. Question sign is also sleeping. Tanu, she has disappeared. No, she has come back. Preeti, Niharika, Irfan, Vishal 1303. Are we there? Okay. Now, since we have got the free body diagram of this body, let us write the equation for this body. And what will be the equation? The y-axis will be vertical, the x-axis will be horizontal, x-axis there is no force, so don't worry. What is the equation for this block? Equation of equilibrium. The equation will be T1 equals 10m. Yes or no? Yes or no? Please tell me yes or no. 10m is equal to T1. That is the equation that we are getting from this block. What next? We draw the equation, we draw the free body diagram of block 2 kg, 20 Newton is downwards, T2 is upwards. There is no other force acting on this block. So what will be the equation for this block? Everyone must know this answer. X-axis is horizontal, no force. Y-axis is vertical. The upward force is T2. The downward force is 20. So T2 is equal to 20. We get our first answer. That tension in the string 2 is 20 newtons. Yes or no? Do we understand this? No one understands this? Okay. That takes us to my last block. That might give me the most trouble, but I am not worried. It is kept on a horizontal floor, so normal reaction N is coming up, but my weight mg, which is 20, is going downwards. It always goes downwards. Now how will I make the x-axis and y-axis for this particular gentleman? We know that my x-axis would be along the plane like this, and my y-axis would be like this. Do we agree on this? Yes or no? That these are my x and y axis, sir. And I again told you that this is 20 mg. So this will be mg cos 60. No, not cos 60, cos 30. Mg cos 30. So 20 multiplied by cos 30 is root 3 by 2. So downward force is 20 root 3 by 2. And the rightward force is 20 sine 30. Sine 30 is half. 20 by half. 20 multiplied by half is 10. Do we understand this? So 10 is like this and 10 root 3 is like this. Now I can make two equations, one along x-axis, one along y-axis. First of all, let me mark the free body diagram. This is the free body diagram of this block. Do we all understand this? N is going up like this. 10 root 3 is going down like this. So what is the first equation I get? What is the first equation I get? N is equal to 10 root 3. Do we all agree with this step that I've written? N is equal to 10 root 3. Do we all agree with this step? Can I have raised hand that we understand this, sir? This is the equation which I have written for the block along y-axis. Can I have some raised hand that we understand this, sir? N is upwards, 20 root 3 by 2 is downwards, 20 root 3 by 2 is 10 root 3. Vasant, Tarun, Tanu, Preeti, Niharika, Irfan, Kiran, Vishal. Do we understand this, beta? Okay. Then what about the equation along x-axis? T1 is upwards. So T1 is equal to, what is downwards? T2 is downwards. T2. Apart from T2, 10 is also downwards. T2 plus 10. So T1 becomes T2 plus 10. We already know T2 is 20. So T1 becomes 30 newtons. Do we all understand this? T1 becomes 30 newtons. T1 becomes 30 newtons. As soon as T1 becomes 30 newtons, mass becomes 3 kg. from the original equation number 1. Can I have raised hand in appreciation that we understand this, sir? How we have done this? We have isolated everything. Draw the sketch, then draw the free body diagram. T1 is equal to 10m from the free body diagram of body A. T2 is equal to 20 from the free body diagram of body of 2 kg which is hanging. The only difficult problem was the free body diagram of this body which was kept on this plane. N is upwards, mg is downwards, T1 is here, T2 is here. We make our x-axis. This is my x-axis. This is my y-axis. N is equal to 10 root 3. T1 is equal to T2 plus 10. T2 is 20. So T1 becomes 30 and M becomes 3. Can I have some raise hand that we have understood this? Only 2 people seems to have followed this question. That is not good enough. 1301. Vasant Sai, Tanu, Preeti, Niharika, Mohammed, Irfan, Kiran, Vishal, 1303. Are we all there in the class? Do we understand this? Anyone has any doubt? Please raise your doubt. I'm asking you to unmute yourself. I'm allowing you to unmute yourself. If anyone has a doubt, please raise it. Anything that you have not understood in this question? I guess there are no doubts. If there are no doubts, then you will have to solve this question. And this question is example number 7. Find the magnitude of force exerted by string on the pulley. Yes, Niharika, what is your doubt? You can unmute yourself and ask your doubt. This is the block. This is the string. And this is the pulley. And this question can be asked in your exam. Find the magnitude of force exerted by string on pulley. Yes, Niharika, you are asking me something. In the previous problem, we also had mg downwards. So n becomes 30 root 3. I don't know what you are talking about, Niharika. Mg downwards. Which mg is downwards? Which body are you talking about, beta? Which body are you talking about? If you're talking about this body, where do I see 30 kgs? Where do I see 30 kgs? Do not draw a diagram of things that you don't see. We only draw diagrams of forces that we see. Forces we don't imagine. Where do we see 30 here? Please tell me. Where do you see 30 Newton acting on this body? I don't see it anywhere. So don't imagine things on your own. You only draw forces that you see. You don't draw forces that you imagine. Am I clear, Niharika? So mg is 20. Yes, mg is 20. Mg is 20. We have resolved it into two components, this and this. So this 20 is not relevant now because we have resolved it. This 20 is gone because we have resolved it. Am I clear? Okay. Chalo. What is the force exerted by this string on this pulley? I'm waiting for your answers. I'll keep quiet for 2 minutes and see who gives me the answer first. Anyone with an answer to this example number 7? I am waiting patiently. No one? Waiting for your answers, beta. Shall I do it? Shall I do it? No one is able to solve this? At least tell me yes or no. Okay. Then I will solve it. It's my humble duty to solve this. How are we going to do this? First step, draw sketch. Sketch is already there. Second step, draw the isolate everything. Draw free body diagram. I don't need to isolate. I will draw the free body diagram here. Third step, draw the free body diagram. So let me draw the tension. Only one string, tension T. Only one string, tension T. Tension T. Tension T. The only force acting on this block is 10G downwards, which is 100. This is the free body diagram of this block. T is upwards, 100 is downwards. T becomes equal to 100 Newton. Do we get this answer, everyone? T is 100 Newtons. The tension in the string is 100 Newtons. Did we get this answer? Yes or no? We got this answer, everyone? Yes. Now, we never talked about the force on the pulley. Here, there is a problem that there is a force on the pulley. How much is the force on the pulley? Now, see, this is the diagram of the pulley. There are two tensions acting on the pulley. They are not upwards or downwards. One tension is like this, T. The other tension is like this, T. Both the tensions are at 90 degrees. Do we remember this? Do we understand this? From the free body diagram of the pulley, do we understand this? That there are two tensions acting on the pulley. Leftwards, downwards, T and T. Yes or no? Do we understand this? Yes or no? So what is the next force acting on the pulley? This now question becomes a simple question that there are two forces A and B acting at 90 degrees on one body. What is the resultant force? Resultant force is given by A square plus B square plus 2AB cos theta. Do we remember this formula from vectors? Two vectors A and B are at an angle theta. What is the resultant? A square plus B square plus 2AB cos theta ka under root. Do we remember this? here the angle between the two vectors is 90 degrees. So what will be the resultant force? Under root of t square plus t square plus 2 times t into t cos of 90. Cos of 90 is 0. Do we remember this? Cos of 90 is 0. So this goes away and your final answer becomes 100 root 2 Newton. 100 root 2 Newton. Do we understand this? This is the force exerted by tension on pulley, and this pulley is attached to this hinge or rod. So whatever force tension is putting on the pulley, same force hinge is putting on the pulley, so that the net force on the pulley is 0. So the force applied by the hinge is also 10 root 2 newtons. Do we understand this? What I have done here? Can I have some raise hand that we understand this, sir? How I found out? How I found out the force applied by tension? Force applied by tension on the pulley, and how I have calculated the force applied by the hinge on the pulley. What about the others? Vishal, 1301, Vasant Sai, Tanu, Preeti, Mohammed, Kiran, 1303. Do we understand this, beta? If you understand this, then comes a problem from your notes. Problem number 10. These are the problems that you will be encountering a lot in your exams. These type of problems. So it is prudent that we do this. Problem number 10. A mass M is suspended by a rope from a rigid support P. As you can see, this is a rigid support P. Another rope is tied at the end Q and is pulled horizontally with a force F. If the rope PQ makes an angle theta with the vertical, what is the tension in the string PQ? What is the tension in the string PQ? So as I can see, there are 3 strings here. This is string number 1. This is string number 2. Can you solve this question on your own? 2 minutes you shall get, and I will keep quiet for 2 minutes. Anyone there with any type of solution for this question? How will you do this? Simple. Draw a sketch. Sketch is already there. Isolate all bodies. I only see one body. Draw the free body diagram. Let us start drawing free body diagram. Let me call tension here as T1. Tension at this point will be T1 like this. This will be T2 like this. And this will be T2 like this. Okay. Then I draw the free body diagram of this block. This will be mg. So this is my first equation that I got. And the first equation that I got is T1 equates mg. Do we all understand this, that T1 equates mg is the first equation that I get? Did you get all this equation? Please raise your hand if you got this equation. T1 is equal to mg, this equation. How many of you got this? Niharika got this. What about others? Irfan, Abhiram, Tarun, Tanu, Prashant, Preeti, Vishal. Okay, now I go and I'll just enhance your view here. Oops. Now I go to this point and I draw the free body diagram of this point. Point does not have any mass, so don't worry about the mass. What are the forces acting here? T1 is acting here like this. Now we know that T1 is equal to mg. Do we all know this? Yes or no? T1 is equal to mg. Now there is one force T2 which is acting like this, T2. And there is one force F which is acting like this. Yes or no? And I also know that this angle is theta. I'm drawing the free body diagram of this point. Now I must understand that this point must have some x-axis and y-axis. This would be the y-axis. We all understand this? We are now mature enough to understand this. And this would be my x-axis. Yes or no, everyone? X and Y, I have drawn it in light color so that you just have an idea of this is your x and y axis. Now, if you look at T2, T2 is going in this direction. So I have to resolve this T2. How will I resolve this T2? Along x-axis and y-axis, this angle is theta. So this angle also becomes theta. So this side becomes T2 cos of theta. And this side becomes T2 sine of theta. Do we understand this? That the upper one becomes T2 cos theta and the left one becomes T2 sine theta. Do we understand this, everyone? Can I have raised hand that we understand this, sir? Yes or no? And that's it. That is what we were looking at. We had to find out the tension in the string PQ. So we had to find out the value of T2. How will I get the value of T2? T2 sine theta is equal to F. T2 sine theta is here, F is here. So your T2 becomes F divided by sine. Do we understand this? Can I have some appreciation? Can I have some raised hand? That sir, yes sir, we sir, understand that sir. No problem with that one, sir. We all understand this, sir. Yes sir, no sir. Better you go, sir. Better I understand, sir. Yes sir. Okay. Are you now confident enough of solving one problem which came in IIT JEE? And the problem, you will say, sir, why IIT JEE? We are from NEET. But you must understand, beta. Problems are same. Problems are same. So here is a problem that we are going to attempt. IIT JEE 1985. Spring balance. You must be assuming what is the spring balance. Spring balance is something that is used to measure weight. And what does the spring balance measure? You must have seen those vegetable walas or that kabadi walas. When they come to your house, they have this balance, which is they hold it like this and it has a spring. That is the spring balance. Spring balance. It shows the tension in the spring. A spring balance has a reading of 2 kg when an aluminum block is suspended from it. Another balance B shows a reading of 5 kg when a beaker full of liquid is placed on its pan. So this is placed on a pan. The two balances are arranged such that the aluminum block is completely immersed in the liquid as shown in the figure. Wow. What will be the reading in the balance? The reading of spring balance A will be more than 2 kg. The reading of balance B will be less than 5 kg. The reading of balance A will be less than 2 kg and of B will be more than 5 kg. The reading of balance A will be 2 kg and B will be 5 kg. What do you think is the answer? So, you have a block, you suspend it by a spring balance, it reaches 2 kg. You have a beaker full of water, you put it on a taraju, you put it on a balance, it reaches 5 kg. Now, you put this aluminum thing inside this, and then they are asking you what will be the reading in this spring balance and what will be the reading on this pan. What is the answer, my dear friends? Now remember, whenever you immerse something inside liquid, that liquid exerts an upward force on it. Do we understand this buoyant force? Have you heard this term buoyant force? If you have not heard this term buoyant force, then you would not be able to solve this question. This buoyant force is exerted on the liquid, on the solid by the liquid in the upward direction. So what will happen? The reading of this, the apparent weight of this will be reduced, and hence the reading on the balance A will be less than 2 kg because the net force will be reduced. So reading on balance A will be less than 2 kg. Now the liquid is going to exert a force upwards. So this block will exert a force downwards. So the total force on the beaker will increase, and hence the reading of balance 2 will increase. So the answer is reading of balance A will decrease, reading of balance B will decrease. Whatever questions have been asked previously in G, they can be very well asked again in NEET or JEE mains. And that is the reason of me doing this question at this point in time. Do we understand this, beta? Do we understand this? Can I have some raised hand that we understand this? Some raised hand will give me more confidence that we have understood this question. Only 2 people seems to have understood it. That is not good enough. I will need a more thing. Okay. Comes this one. These type of questions can definitely come in your exam. Problem number 1313. In the following figure, the pulley is massless and frictionless. What is the relation between T1, T2, and T3? T1, T2, and T3. 1 minute, you will get. Give me the answer. T1, T2, and T3. What will be the ratio between T1, T2, and T3? And what are your answers? You can very well understand that T2 and T3 are tension in the same string, so they will be same. Even T1 is a part of the same string. The string goes like this and then it goes like this, or the angle here is both same, so it has to be a part of the same string. So T1, T2, and T3 are tension in the same string, and hence they have to be same. Yes or no? Do we understand this? Do we understand this question? Can I have reason that we understand this? Vishal, Vasant, Tarun, Tanu, Niharika, Irfan, Kiran, Abhiram, do we understand this? All the three are part of the same string, and therefore the tension will be same in all the three parts. Yes or no? Okay, then we come to the last question of today's class. We will be finishing your equilibrium question, equilibrium part with this question, and this comes now. You will have 2 minutes to solve this question. I will keep quiet for 2 minutes. This is the question for you to solve. I will read the question. A man of mass small m stands on a crate of mass capital M. He pulls on a light rope passing over a smooth pulley. The other end of the rope is attached to the crate. For the system to be in equilibrium, what is the force exerted by men on the rope? Solve this. 2 minutes. Bunny? Has anyone got the answer for this question? Has anyone got the answer to this question? No one? Well, you have to go step by step and solve this problem. Let me draw the diagram first. So this is a pulley, and then this is a crate on the pulley. And then there is a person here. He has his hands, and this is tension in the, and this is the string. Now, what will I do? Since this problem looks a bit complicated, I will isolate and I will draw the free body diagram separately. So I've isolated the two bodies. This is the crate, and this one is the man. What are the forces acting on the crate? One is the weight mg, which is downwards. Then there is tension in the string T, which is upwards. This man is standing on this crate. So this man is going to push this crate down with normal reaction. So there will be a normal reaction N, which is acting downwards on this crate, which will be given by the man. So this becomes the free body diagram of the crate. Do we understand this? Yes or no? T is upwards, its weight mg is downwards, and the normal reaction is downwards. What about the free body diagram of this gentleman? There is a tension T, same string, tension T upwards, mass of the man, small mg downwards, and then there is a normal reaction coming from the crate, which is N upwards. Yes or no? Do you understand this? Normal reaction N, which is given by the crate on the man upwards, normal reaction by man on the crate downwards. Do we understand this? Yes or no? Can I have raised hand that we understand this, sir? So, what is the equation for this block? T is upwards. T will be equal to N plus capital Mg. Upward force is equal to downward force. Equation from this crate. What is the equation that we get from this man? T plus capital N is equal to small mg. This is the equation that we get from this block. This is equation number 1. This is equation number 2. How do I solve this? Add both 1 and 2. If I add both 1 and 2, what I get? 2t plus capital N on the left hand side will be equal to capital N plus capital M plus small m times G. Do we understand this? N say N getting cancelled. My T becomes capital M plus small m times G divided by 2, and that is the answer for tension in the string capital M plus small m times G divided by 2. How did I get this? Doing simple things. I draw the free body diagram of the crate, the box, and the man. For the man, normal is upwards, T is upwards, weight is downwards. For the crate, T is upwards, weight and normal reaction are downwards. I got equation number 1, I got equation number 2. I equated, I added both the equation, normal reaction getting cancelled, and I have T is equal to capital M plus small m times G divided by 2. Do you understand this? Can I have some reason that you understand this, sir? Great. So this was all that we had to do in this particular subtopic of equilibrium in this chapter. There are more questions given in your notes. Find time, please solve them. More solved problems are there. The DPPs will be put on your app very soon. So I hope that you solve as many problems as possible. In the next class onwards, we'll be doing some problems on acceleration, because if the body is not in equilibrium, it will get into acceleration, and we'll be getting on into Newton's second law of motion. That will be there in the next class. I hope to see you in the next class. Till then, take care, stay happy, stay safe. Bye bye.